Well, our today's topic is momentum. Means in most of the cases, momentum concept is applied for conservation of momentum. And the first question I have selected from paper 9709/43 for the session May June 25, and we are going to solve question number 1. We are going to solve question number 1 of this mentioned paper. Let's read question number 1. Two particles P and Q of masses zero point 0.1 kg and zero point 0.3 kg respectively are at rest on a smooth horizontal plane. P is projected directly towards Q with speed 4 meter per second. At the same instant, Q is projected directly towards P with speed u meter per second. After P and Q collide, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Find the two possible values of u. Well, from the question, one information is very distinct and clear, which is before the collision, P and Q are moving towards each other. That means their direction was different before the collision. But what happened after the collision? Nothing has been clarified about the direction after collision. So there will be actually four possible cases for the direction of the particles after collision. So before collision, it looks like, look at this, suppose this is P and another particle is Q. They are just moving towards each other. They are moving towards each other and they collided. So it is very sure that one of them will be negative. We can suppose anything to be negative because their direction was opposite to each other. So let's start writing our solution. So this is the first case. It may happen that after collision, both the particles are moving to the same direction. That means both of them will be positive, either positive or negative, whatever. So let us write the concept of the conservation of momentum, and the formula for concept of the conservation of momentum is, mp into initial velocity of p plus, not plus, yes, it will be plus mass of particle p and initial velocity of, not particle p, it is particle q, and initial velocity of particle q, I mean uq. Okay, equal to mass of, as we are applying conservation of momentum, so mass of particle p and final velocity of p plus mass of particle q and final velocity of particle q after collision. Then we are going to substitute the values. We do have mass of particle p is zero point 0.1 and mass of particle q is 0.3. So zero point 0.1 and initial velocity of particle p was u, sorry, it was 4u. For p it was 4u, and for q initial velocity before the collision what was u. So zero point 0.1 into 4u, as their direction is opposite to each other. Let's say q is directing negatively, so it is going to be mass is 0.3 and velocity is point, velocity of q before collision is u. Then after collision, let us think both of them are moving positively. So mass of particle p is zero point 0.1 and after collision p is moving with 2 meter per second speed and q is moving with 4 meter per second. So it is 2 plus mass of particle q was 0.3, which was moving with the speed of 4 meter per second. Let us calculate. So it is 4u and 3 minus 3u, that is 0.1 u. 0.1 u, and on the right side if we calculate, 2 ones are 2, 3 fours are 12. So 12 plus 2, that is 1.4. 1.4. Hence if we divide 1.4 by 0.1, it is going to be 14. U is equal to 14 meter per second. This is the first case, first value of u. So case number 2 is it might happen that particle P was moving backward and Q was moving forward. Okay, so that means we will apply the same concept, conservation of momentum. Let us write MP into initial velocity of particle P plus mass of particle Q and initial velocity of particle Q equal to, now direction has been changed as they are moving opposite to each other. Let P be negative. Okay, so mass of particle, not over here in the second step we can write. In this step it is just applying the formula mass of particle P into final velocity of particle P plus mass of particle Q into final velocity of particle Q after the collision. Well, then we are going to substitute the values. So before collision it is actually same as we have used here. We can copy zero point 0.1 into 4u minus 0.3 into u equal to mass of here. Look at this, we are supposing P is moving backward, that's why the negative symbol will be in front of P, which is zero point 0.1 into 2 plus into 2 into 2 plus mass of particle Q is zero point 0.3 and final velocity was 4 meter per second. So on the left side it is actually all the same. It is going to be 0.1 u. 0.1 u is equal to from 12, if we subtract 0.2 it is going to be actually 1. Okay, now if we divide 1 by 0.1 it is definitely 10. So our second value of u is 10. Now case number 3. So is case number 3. Before the collision, their momentum will be same. Sum of the momentum. So M P mass of particle P into initial velocity of P plus mass of particle Q into initial velocity of particle Q is equal to mass of particle P into final velocity of particle P plus mass of particle Q into final velocity of particle Q, and the initial velocity will remain same. We may use negative symbol in front of P also, but we are not doing, just for showing this actually. So it is left side is going to remain unchanged, 0.1 0.1 into 4u minus 0.3 u is equal to, now let Q be negative. Okay, so P will remain as it is, 0.1 into 2 minus mass of particle Q is 3 and final velocity was 4. So on the left side what is it going to be? It's all the same, it is 0.1 u. 0.1 u is equal to, here from 12 if we subtract 2 it is negative 1 point negative 1. Okay, hence u is going to be actually negative. Okay, our u is going to be negative how much? 10. Negative 10. Here there is a decimal point, it is left side is always same. So u is negative 10. Now if we go back to our question, look at this. In the question it is written speed is u meter per second. U was actually a scalar term which doesn't have any direction. Okay, so u cannot be negative, speed can never be negative, remember. That's why we are rejecting this value. Let us reject this. Okay, then the fourth possibility, if we use the fourth possibility also, we will find that u is negative. Okay, I believe that there is no necessity of explaining, I mean writing case 4. Case 4 will also be similar to the case 3. Actually, if we suppose both of them after the collision both the particles P and Q are negative, then it will show actually negative value of U. Negative value of U is rejected. So what are the possible cases, what are the possible values we can take? We can take the values of these U is equal to 10 and U is equal to 14. So let us write here answer. So these are the two possible values of U, and the rest of the two values will be negative, which is rejected. I think you got my point. Now let's move on to the next question of the same topic. The next question has been selected from paper 9709/41 for the session May June 25, and the question says P is now projected on a smooth horizontal surface with speed v meter per second directly towards a particle Q of mass 1.25 kg, which is stationary. After P and Q collide, the velocity of P is w meter per second and the velocity of Q is 2w meter per second. The loss of kinetic energy in the collision is 25 joule. Find the value of V and the value of W. As this is the part of question A, so we will have to pick up some values from A. From A, let me start the solution. From the previous solution, we have come to know that MP, that means mass of particle P is MP is equal to zero point 0.5. 0.5. Well, 0.5 kg, that means mass of particle P is 0.5 kg. So let us apply, as this is the energy lost before and after collision. That's why we will have to apply the concept of the conservation of momentum. And the concept of the conservation of momentum, you know that mass of particle P multiplied by initial velocity of particle P means before the velocity before collision, and mass of particle Q multiplied by initial velocity of particle Q is equal to mass of particle P into final velocity of P. That means final velocity means the velocity after collision plus mass of particle Q and final velocity of particle Q. Okay, so mass of particle P is, we have already written, it is 0.5, and initial velocity, I mean velocity before the collision, velocity of particle P before the collision, it was v meter per second, v, and mass of particle Q is 1.25, which has a velocity of 0 because it was in stationary motion. So mass of particle P is now zero point 0.5, and after collision the velocity of particle P was w meter per second, so it is w, plus mass of particle Q was 1.25, 1.25, and final velocity after collision, final velocity of Q after collision was 2w, 2w. If we simplify, it is going to be zero point 0.5, and this is 0.5 b, 0.5 into velocity is equal to, so 0.5 and it is going to be 2.5, so that is going to be 3w, 3w. So first of all we express v in terms of w, so v is going to be, hence v is going to be 6w, 6w meter per second. Okay, I think meter per second is unnecessary to be written because already it is written with each of the speed. Now for this we will have to apply the loss of kinetic energy, the concept of the loss of energy. Look, though this doesn't belong to our mentioned topic, but it is required to be applied for obtaining our values of V and W. That's why. So let's write loss of kinetic energy. Loss of kinetic energy. Loss of Loss of energy is already given. How much is the energy lost? It is 25 joule. Here it is written 25 joule. So lost energy is 25 joule. Okay. Now what is the formula for loss of energy? For loss of energy, we know that is change in, it is negative definitely because energy was lost. Change in kinetic energy of particle P minus change in kinetic energy of particle Q is equal to 25. Okay. Now you know the formula of change in kinetic energy is half mv square of which particle? Particle P minus half of mass into v square, that means final velocity of, not final velocity, this is actually difference between the initial and final velocity, equal to 25. Okay, now here, so let us substitute. This is more 0.5 into mass of particle P was zero point 0.5 into zero point 0.5. And look, v square, in case of change in kinetic energy, it is actually difference between the final and initial velocities. V square doesn't mean that only final velocity. So final velocity of particle P was what? It is written final velocity was w square. Look at this, it is written here w meter per second, so it is w square. And initial velocity before the collision, it was, initial velocity of P was v meter per second, and v is what? 6w. So let us write 6w squared. Okay, so this is our first quantity. This is also this, minus the second one. For the second one, minus half, and mass of particle Q is 1.25, 1.25. Final velocity of particle Q was 2w. Look at this, it is written here 2w, so we will write 2w square means 4w square. And initial velocity was actually 0 because particle Q was in stationary mode. Now if you simplify, what is it going to be? Negative 0.25, 0.25 into, it is no more negative. Look at this, 6 square is greater, so it is no more negative. So 0.25 and 36 minus 1, so it is actually 35. 35w square, 35w square minus, this must be negative. Look at this, 4, 1.25 means actually 5. If 5 is divided by 2, it is going to be 2.5. So 2.5 w square, and our right side is 25. It should not be forgotten, right side is 25. Let us write 25. If we simplify the left side, it is going to be 6.25 w square, 6.25 w square, and right side is going to be 25 as it is, equal to 25. Hence our w is going to be, if we divide 25 by 6.25, it is going to be 4. Square root of 4 is going to be 2, and it must be positive because w was speed and it was positive speed. That's why our w is 2. Now we can write w is 2 when w is equal to 2, when we are supposed to find the value of v also. V is 6w. V is equal to 6 into 2 means 12. It is 12. So the value of v is, w was 2 meter per second. Let us write here w is 2 meter per second, one of the answer. though meter per second is not necessary to be written because unit is given with the quantity, and our value of V is 12 meter per second. So that's two are the answer we should found. We should find these two answers. Okay, W is equal to 2. They have told us to find the value of V as well as W. So V is 12 meter per second and W is 2 meter per second. Only two, writing only 2 and 12 is sufficient. So I tried my level best to explain every part. Um, I believe that you have understood my calculation.